All right, so this is problem 55 here. And let's go to the problem itself. I drew out a diagram already. Let's see here. So problem 55 basically says soccer goal is 2.44 meters high. A player kicks the ball at a distance 10 meters from the goal. At an angle of 25 degrees. The ball hits the crossbar at the top of the goal. What's the initial speed of the soccer ball? Okay. So I'm going to post that over here just because we're probably going to need to reference it at some point. So that's 25 degrees right there. Okay. So, and then I'm going to make, so here's my, hopefully this is nothing. I just drew a diagram here. I got my initial velocity. Here, but then I split that up into, that should be V naught y and Vx, right? So like we do with most projectile problems. And then I'm going to set my origin to be where the soccer ball is at the beginning. So, and then that means that the soccer ball at the end, it's going to hit the goal at the top here. And it's going to hit the goal at a height of y. So this is a height of y. And then a distance x that it goes, so displacement x, that it goes in the horizontal direction. And there we go. So, and I can get already, right, hopefully you get this trigonometry that V naught y equals V naught sine of theta, or 25. I'm going to try and do this algebraically. If it gets too messy, if it gets like, where it's starting to drive me nuts, I might just plug in numbers for simplicity's sake. But then I can also now get Vx. So Vx is going to be V naught cosine theta. So that's kind of using trigonometry right there. Okay, and then now I'm going to do things I know and don't know. So Vx, x naught, x, t for a projectile. There's no acceleration in the horizontal direction, so there you go there. And then we got V naught y, Vy, Ay, y naught, y, and t. So I placed my origin where the object is at the beginning. So, and again, this is my initial moment, and this is my final moment. So my initial moment is when the soccer ball gets kicked, and then the final moment is when it hits the bar there. Okay. So I'm going to say x naught and y naught is 0 because that doesn't really change. This is a free fall problem, right? So the acceleration due to gravity is going to be negative g. And then we're trying to find out the initial velocity. So we're trying to find out the initial velocity. I also know that Vx is going to be V naught cosine of theta. And I know V naught y is going to be V naught sine of theta. Is there anything else I know? So I'll just say that, we're just saying this is a distance x and this is a distance y. Yeah. So that's just what I'm calling it right there. And what do I know? I know, so I got to find everything in terms of theta. The soccer height I know, so that's y. That's the height. I know how high the soccer height is. And I know the angle, so that's about, distance. I know x as well. Distance is 10 meters. So again, I want to relate. So I'm trying to find, it's something I don't know if necessarily has been asked of you yet, is we're trying to find V naught. So what I'm going to do is I'm going to try, it looks like, right, I know this. I know theta. So I'm going to try and see what the heck this will get me. I know mostly we start with the y stuff because y dictates the time. But I think what I'm going to need to do is actually get equations for here and then combine them in some way. Because V naught is in both the horizontal direction and the vertical direction here. So I'll start with this equation that x equals x naught plus Vx times t. So I'll start there, and then we got x, which we know, is equal to 0 plus V naught cosine theta times t. And then that leaves me with this. So I got now Let's do this a little like that. So we got that. Okay. So there's one relationship right there. I'll call this equation 1. All right. Let's see what else I can do here. You know what? I'm going to isolate t. I'm going to isolate t before I do that, because I think I'm going to need to plug in times here. Yep, okay. So I'm going to isolate t. Yeah, this is what I'm thinking. It might get a little ugly. I'm sorry, but I think I know where we're going here. So, all right, here we go. So here's equation 1. And then next up, I'm going to use beta here. So, and my reason why is because I know, you know, yeah. I might have, you know what, if I was doing this maybe the first time, I might have tried this. I don't think this is going to work because I don't know this, and I don't know this, and I don't know this. So like that's where I'd have an issue there. Here I know a little bit more. So this comes down to y equals 0. This is 0. Plus v naught y is v naught. Sine of theta times the time plus 1/2 times the acceleration, which is negative g t squared. So simplifying this a little bit, you're going to get y equals v naught sine of theta t minus g over 2 t squared. And what's nice about this now, so again, I'm looking, so I know this, I know this, I know this, and I'm looking for v naught, right? So I think I'm thinking all I need to do, again, it looks a little ugly, but I'm going to, this is t here, so here I'm calling equation 2, and I'm going to plug in equation 1 into equation 2. So I'm going to plug in 1 into 2. So I've isolated for the time, and it's just going to plug in times in there. If you notice, though, there's time here and time here. But I think this will get me my answer. So this will get me to, so let's see, let's plug everything in here. Again, it's going to look a little messy, but I'm still okay with this right now before I crash and decide I'm just going to plug in. So this is x over v naught cosine theta. So we got x over v naught cosine theta minus g over 2, and then again we got x over v naught cosine theta squared. And I think I know everything now, right? It's just now isolating v naught. So I know y, I know theta, I know theta, I know x, I know x, I know theta, I know g. So all this is now just going to be isolating v naught, which, as you can see, is not necessarily going to be an easy task. So let's see what we can do here. So some things that are going to cancel out right here. V naught cancels out with v naught here. I can simplify, for those of you who know trigonometrics, right? I got sine of theta over cosine theta times x minus, let's expand this. This is going to be x squared, gx squared over v naught squared cosine of theta, cosine squared of theta. So, oh, well, this is good. I only got the v naught, so it's not like I need to do a quadratic or anything like that. That's a good thing. But this simplifies even more, does it? Or is it going to be easier to? Well, yeah. Let's go with we'll just say this is tangent of theta, right? Because sine of theta over cosine theta is tangent of theta times x. So minus g over 2 x squared over v naught squared cosine squared of theta. So I'll subtract tan theta x from both sides. Or you know what? I'll instead to keep the v naught. So I'm going to add this term over here, and then I'm going to subtract y on the other side. So this is going to get me to g over 2 x squared over v naught squared cosine squared of theta equals tan theta times x minus y. Next up, I'm going to multiply by 2 over g. That'll cancel out this. And then over here, so this is all multiplied by 2 over g. So now I got x squared over v naught squared cosine squared theta equals 2 over g tan theta times x minus y. All right. So I'm now, where my brain is going might not be where your brain is going. I'm thinking now I'm just going to multiply everything by, yeah, I'm going to multiply everything by, trying to think of a simple way to do this, but I can't. So, you know what? Let's multiply everything by v naught squared. So this will cancel, this will cancel. So then I got v naught squared over here. All right. And so now I'm just going to, so now that I got that, so I got x squared over cosine squared theta equals 2 over g tan theta times x minus y, and then v naught squared. Now I'm going to divide all this nonsense. So all of this nonsense I'm just going to divide by both sides. And that'll give me, or you know what, to make this a little easier on you, I'm going to multiply by all this nonsense. Multiply by 1 over all this nonsense. So I'm going to multiply everything by 1 over nonsense. Blah. Because if I multiply by 1 over nonsense, this cancels with this. And I'm left with v naught squared only. So now I got this multiplied by what I have here, x squared over cosine squared of theta equals, please let me know if I make any math errors, v naught squared. And that's pretty much it. Now I need to take the square root, so it's going to be the square root of 1 over 2 over g tan theta x minus y, all that, x squared over cosine squared theta, so all of that equals v naught. So now it's just plugging everything in. Why the heck not? Let's do this. People who are seeing me on my camera, I need to use my phone, so I'm sorry. See ya. Let's see, so plugging all this in, that's going to be the square root of 1 over 2 over 10 times tangent of, I think it was 25, multiplied by x, which was 10 meters away. So x is 10, y is, so x is 10, minus y, which was 2.44, I think. Yep, 2.44. All right, so there's that part. And then this we got x, which is 10. So 10 squared over cosine squared of theta, which is 25. All right, let's see what this looks like. So let's start with 10 squared is 100. I'm starting over here. And then I'm going to divide by cosine of 25. Am I in radians? No, I'm not good. Of 25, and then all that squared. Oops. I'm getting 121.7. So this comes down to 121.7. And then multiplied, let's see if we can do all this nonsense. 2 over 10 is just 1 over 5. So I could throw a 5 up here. Make that a little bit easier on me. I got tan of 25 times 10 minus 20, or 2.44. So tangent of 25 times 10, answer minus 2.44, and then 5 divided by all that nonsense is 2 so this is now reduced to 2.249. That's probably way too many decimals than I need. 121.7. So I'll multiply those. 121.7. Take the square root of all that, and I get 16.5 meters per second. And I don't know if that's the answer. Hopefully it's the answer, because I just made a whole video on this whole thing. So, yeah. There are questions from people, comments, concerns. And I will cut away